Hello, it's 1 p.m. now and you're sitting in room 5. So if you have read the schedule right, that means you're in the ChaosVPN CTF gaming network talk. So I'd like to get some information about the audience first. So who of you is involved in a hackerspace? Who of you is involved in CTF gaming? That's a bit less, but also interesting. Okay, and who of you has experience with network? Good. Okay. This talk is about ChaosVPN, CTF gaming network. Who we are? Root. This is Jens Mücke. He's an OpenWRT developer. He codes for his daytime job. And he has written a lot of the code we needed to write. Then we have Vyrus. He's with DC949. He did the OCTF or worked with the OCTF 1 to 5. He's layer 1 needs to be mentioned. I don't want to read all the slides. You can read that. Yeah, he's one of the co-founders at Nullspace Labs and did some other interesting things, especially regarding CTF, capture the flag network, hacking networks. Then we have Eric Taves. He's from the Chaos Computer Club Darmstadt. He studied computer science. He's working at the TU Darmstadt now and is interested in cryptography, cryptanalysis and stuff like that. You might know his software to break WEP in less than 60 seconds. Oh yeah. And then there's me. I'm from the Chaos Computer Club Hamburg. I'm an administrator for the daytime job. I played a lot CTF with the University of Darmstadt. For example, USB CTF. Some of you might know Cypher and DA Open. Together with some people, I co-hosted the CCC CTFs. And I like to travel hackerspaces and have some friends around the world in different hackerspaces, which I'd like to communicate to. Any questions for the speakers? So, I will explain how we got to all of this. So, has any one of you been on Hackers at Random? Some? See 2 or 3? Hackers at Random is a Dutch camp, hackers camp in usually the swamps somewhere. This time it was not too bad. We talked a lot about that. It is a problem to communicate on the network between the different hackerspaces. Also, we wanted to play CTF, and we were playing CTFs. But you know, hosting a CTF is a lot of work. And most of this work is the same work all over again. It's the network setup. So there was an idea born. We wanted to play CTFs in our rooms. Most of us had hackerspaces. And this required a VPN setup. And to reduce the work on that, we decided to make this VPN setup permanent, or wanted to have that permanent. If you don't have to set it up all over again, that saves a lot of work by doing a CTF. And you can understand that if you do a CTF, which is a lot of work, you want to reduce the things that you have to do all over again, which is not too interesting. Like, it's interesting to write a service, but it's not too interesting to set up the network again and again and again. ChaosVPN, we'll explain that. Fulfilled most of the requirements somehow, but not all of them. And with ChaosVPN, we had a lot of experience with that software and with tinc. So we needed to redo ChaosVPN. Okay, I think at this point I should explain ChaosVPN. ChaosVPN at that point was a meshed VPN that's used to host the Chaos phone, which is the asterisk phone service the Chaos Computer Club has among their spread hackerspaces. So we have a big asterisk system, and we used tinc and some Perl code on some Debian boxes to connect them, all of them together, and to have a phone system within that, because you can understand that we would like to have a phone where, well, just we are listening. Okay, the involvement on the idea, we need to talk on the 2063. We're kind of leaving the shadow, like telling people what we are doing and we are planning to do. The things done there was the rewrite of the code to see. We'll explain the reasons after that. And we got a lot of more people involved in that. So, the idea. We wanted to have privacy on the network. Sure, you don't want to have your internet access provider and his deep packet inspection looking directly in your packets all the time. Also with the times that providers, for example, fake DNS and other stuff, which just leaks out a lot of information of the web pages the people use in the hackerspaces. We want to get more of that private. And especially the thing we wanted to get private is the traffic between the hackerspace. Well, there virtually was very few between those, but we wanted to have, if we have private traffic between that private. The community, that all was to connect the hackerspaces and our friends and the whole hackerspace thingy, and to play Warzone. But the first step was to redo this network and then use this network to play Warzone on that. Jensen. Oh. The availability was a problem. We want to have a setup that is really robust and has a solid uptime. So a lot of those VPN installation in the hackerspaces have the problem that they are, you might know that, working somehow. We wanted to avoid that. Well, speed, if you do, don't want to be limited by the VPN stuff. We wanted to have fast network. For sure there's some FTP and other data transfer maybe later going on. And also with speed comes the latency. If you want to do CTF, and especially if you want to do VoIP, you need no low latency. It should be easy to use, so maintenance not very complicated, and neighborly. Join your friends, block your enemies. So what we came up basically was a meshed-based, encrypted and authenticated private network that administrates itself. I'm going to explain that. Meshed. The meshed thing is the biggest difference in compared to most VPN installation. In meshed, everybody's communicating with everybody. So if you set up tunnels and you have two spaces, you need one tunnel. If you set up a system between three spaces, you need three tunnels. You will see that this in the end scales with O equals n square. So tinc defines endpoints and not tunnels. This just is n, so scales way better. The latency is better if all the hackerspaces just communicate to each other and not over certain routing hops. You get a high bandwidth because you're just limited between those two connections and the connection in between, but you're not limited, for example, on the speed of some root hubs. We don't have a single point of failure in there on the network base. So if any node can die and just this node will be off the network, not the whole network. And very important, nobody will see the traffic from other people in the default configuration. If you want to, you can also fuck up this one, but it's pretty hard. Any questions on that? Encrypted and authenticated. Well, this is easy. You should want to have strong encryption that people who may be able to tap the line will not be able to do it while tapping the line. And also we want to mask the traffic details, so somebody tapping the line cannot easily see what is going on there. You can do statistics over encrypted traffic and guess what's going on there, but well, I think you know all that. It's just better this way. And authentication, we want to know who we're talking to, for sure. Private network is clear. We want to have the private network to connect all this. Administrates itself. That is an important point because this is the reasons that some earlier tries to set up a mesh between a network between hackerspaces and stuff like this went down. That basically means if a node joins the network, no other node should need to do something. Tinc, for example, and all those mesh-based approaches in before had the problem that if somebody joins the network, every administrator has to touch his config files, which sucks and does not work, as you know that. And if you get over some time zones, this will just not be very good. So the problem of tinc is keep the config in sync. And if you have a problem that can be solved with writing a program, write it. So we did. Yeah, this was the network based around the ChaosVPN before, who mostly run the VoIP of the CCC. Had 7 years of uptime. I think that's a pretty good uptime. Lesson learned from the first version from the network. You sometimes in tinc have the problem that some administrator by mistake, this happens more often, or somebody who will try to annoy you, announces the wrong network. And that is hard to get rid of. To explain that a bit, if you have a wrong network in your mesh cloud, which is a /24, you can announce 2/25. This is more precise, and then you can take over the information again. But this does not work with the /20/32, obviously, and we had some important servers with the /20/32 in the network. Also, Perl was required, and if you want to put this on an embedded device, and our idea was to have it on an embedded device, if you put Perl on an embedded device, there's not a lot of space left on this embedded device usually. So, the software.
Yeah, welcome. I hope you don't have a hangover from the party last night. So now it's a little bit more technical. So basically, we had this awesome software called tinc, which do all the VPN, but we had to do something for the configuration to get that in a good state running. Basically, what our software is doing is it wraps around tinc, provide a ton device which is needed for tinc, read the local config file and knows what it has to do, like which address it has to download the config. So it fetched the network config, so it knows about all hosts and where it has to connect to, which IP address and that stuff. And then it creates the config file for tinc with all the host files, all the up and down scripted, all that is needed for tinc to run that network. And at the end, it started. That's basically it. We do it a rewrite, so the first version was done in Perl because it's easy to write it in Perl and it works pretty good, except there's some mistakes McFly already told. We decided to do a rewrite and see more about that later. And I really want to thank Higer and HC for taking that software with me, because it wasn't only me that did that part. So, the network file. So your local network file contains a public key and a P range for that part you're using. To get all the nodes, it downloads that file from a specific URL which is in your config. Why are we doing that? So we have a solution that can provide more than one network. So we did it for Warzone, we did it for ChaosVPN, it's more known as AgoraLink here. And if you like to do your own network, you can do it easily. Portability. This was very, very important for us, so this is one of the reasons we do a rewrite in C. It now compiles on every major system. We're looking for more. Special thanks for first compile under Windows. I'm not very much into that part. And we really strongly suggest to put it on embedded devices. And this was the main reason we did that part in C, because you don't want to run Perl on an embedded device like a little router. After we did the rewrite from Perl in C to the 2633, we added some new feature to make it more comfortable. One of these features is we have this restart function that it restarts the tincs in a specific interval you can define in your config. And this interval means it checks if there's a new config available, so it requests the HTTP server for the config, and if it gets 304 response, it knows, okay, I didn't have to change anything, so I also didn't have to restart the tinc to get the new config. We added an archive support, which means we didn't have to download each host file. We can download one file and get an archive which includes all the host configuration, the main configuration, all the things you needed. And we also added some signing and encryption, more about that later by Eric, to get a more encrypted part. It also provides HTTPS, but this is different crypto. We didn't want to use it for that. And all that stuff is in around 4,700 lines of code, so it's not that much. We tried to get rid of most of the dependencies, because you can build it on more systems when you have less dependencies. We are still backward compatible, which is the reason why we have this strange config file at the moment. So it's written in Perl style. Sorry for that. But you still can use an old config file with the new software. The only thing is we added new features, so we have to add new config entries, but we set proper default values, so if you don't define that values, there's a default value for that. To make it a little bit more running on all devices, especially embedded devices, we provide a lot of images and archives for all Linux. I think we also will provide a Windows download pretty soon. But most people put it on these nice little devices, Fonera 2.0. This photo is actually from null space, DC949.
It's just null space.
Just null space. We got the experience that these devices running pretty good. They are very stable. They are less power consumption. So especially in Europe, energy is much more expensive than it is here. So we care about energy consumption. So we really suggest to let it running on better devices. You make it ready, it's running, you didn't touch it anymore, and it's running for years. Another reason is to buy these little embedded devices. They are not that expensive. You can get one for 20 bucks. If you want to have a proper one, you can get one for 100 bucks. You can also put an MP3 player on it, and it's basically it's a run device, it's not a PC where other people get their fingers on, install new software, and it's not running anymore. And it's really much more energy efficient. Like a computer is like $50 a month in power, and these devices like $5 in power a year. So in Europe for that. I'm not so much into that crypto part, so I really thank that Eric is here, and I give over to him. Thank you.
So, hello, I'm Eric, and I'm here to talk about the crypto part of ChaosVPN. So, usually, when you write software, you will usually notice very soon when you have done something wrong, because the software starts crashing. Except if you have a security problem or you have a crypto problem, then this won't be noticed for a long time. So, in ChaosVPN, every participant in the network owns an RSA key pair, which means that you have a private key, or you are the only owner of that key, and with the private key you can decrypt some messages, but you're the only one who can decrypt that, and every other participant in the network has a public key, knows your public key, and he will be able to encrypt messages for you, but he will not be able to decrypt messages for you. The ChaosVPN client connects to a server and downloads an encrypted and signed configuration file for ChaosVPN, which is encrypted only for you, and it's signed, so after you've downloaded it you can decrypt it and then check that nobody has altered the file on the server or during the transmission, so you know that this file is authentic. After the file has been decrypted and verified, the client generates a tinc configuration and starts tinc, and tinc can now establish connections with all other nodes in the network, and it can authenticate these other nodes using their RSA public keys. So when two nodes connect, they do an RSA key exchange to establish a session key, and after they have a session they can exchange packets, and these packets are encrypted using Blowfish by default, and they are protected with a SHA-1 HMAC so that nobody can alter these packets. So far, that's reasonably well crypto in ChaosVPN. There are currently some weak points. That means that you can still improve that crypto part. So far, the configuration is distributed over a central server, which is not so good. You would like to have that on multiple servers. However, if the primary server here fails, then this network still stays up. So the network can run for hours, days, or week, even without the central server. The only thing which does not work is that you cannot update your network configuration anymore if the central server is down. Currently, I think there are replay or downgrade attacks possible, so an attacker could not really alter your network configuration, but he could give you an old network configuration, even if there is a new configuration already out there. With tinc or ChaosVPN, it's possible to route packets indirectly between two nodes. So if you have two ChaosVPN nodes all behind a NAT gateway, they might not be able to communicate directly. In this case, you can route traffic indirectly. So far, ChaosVPN does not reuse standard formats for crypto like IPsec, ESP, or AHA to encrypt and protect the packets, but this could be added in a later version. And currently, we don't have perfect forward secrecy in the network. This means if you have a ChaosVPN node running now, and 1 year later somebody is able to recover your private key, then he will be able to decrypt your past traffic. In the future, we would like to have more administrators for the configuration and more distribution points for the configuration. Even a decentralized distribution of the configuration would be nice. And we would also like to give participants of the network more choices in who they trust. So currently they trust central configuration, but you can extend that to a kind of PGP or GPT-like web of trust, so that every participant can select certain nodes in the network he trusts and some nodes in the network he doesn't trust so much. And we would like to have indirected routed traffic in the network, which is only decryptable by the final destination, so that you can route traffic between two nodes who cannot see each other because they are firewalled or whatever, with the assistance of a third node who will be able to pass this traffic through, but he won't be able to decrypt the traffic. Okay. Next part will be done by mc.fly.
Any questions for the crypto part?
You said you were trying to use Blowfish for encrypting all your packets. Like, how well does that work on your tiny embedded devices that probably don't have their own CPU?
It works, so far it works reasonably well. Okay, the question was, how good does Blowfish work on these tiny devices like embedded access points? And the answer is, so far it works reliably well, but this is a configuration option, so Blowfish is the default, but you can extend that to another, you can change that to another algorithm. So, for example, some of these small devices have accelerators for the AES encryption algorithm, because WPA uses AES to encrypt packets, and if you change that to AES, you will more likely get a performance boost.
We have chosen the Fonera 2.0N as, well, reference design, because this is fast enough to host most available broadcast connections you will have at hackerspaces or people spaces where people hang around. Like they can solve up to around 20 to 30 Mbit downstream and upstream equals. So I think that's not too bad. If you have a bigger connection, like if you're in a university or stuff like that, you'll possibly want to use different hardware for that. That is true. Also, if you want to do some hosted servers, don't put an embedded device in front of it to do the crypto if you have like a gigabit internet speed. Then you will just need a bigger computer where you can install FreeBSD or OpenBSD or Debian, for example, or Arch Linux, whatever you want on that. And if you want to play around with the code and the compilers, you can also install Windows or Mac OS X on it.
More questions for the crypto part? Okay, so hand over to mc.fly.
So I'll just shortly explain what the general status of the ChaosVPN is at the moment. And then we will go over to Warzone, which is the second implementation. This is for the playing of CTFs. Like you remember from the beginning, our idea was to build up a network to play CTFs. But for this, we decided to redo the ChaosVPN first, which connects hackerspaces, and you will see what we use there. And yeah, it's starting to get used for CTF stuff. So general status is live, the network works, more and more hackerspaces are joining, IP ranges are compatible with some other networks, and some peers to DN42, which is another VPN exists. Those are, for example, a list of some hackerspaces involved. Like, well, I don't read down all of them. Those are more or less a lot of the bigger and older ones. The maybe more interesting thing is what is up on the network. So we have a DNS up there, voice over IP is used very much, but that can't just be it. So, for example, one of the first things to have an additional use of that network is a rainbow table hash lookup system. Some of you might know Ben Coates and has read his Twitter feed today in the morning that he just upgraded that to a new version. There's a box maintained by him on this network, which is just for the network and pretty fast. I think if you want to try that out, you will find out that you get most of the hashes. I think we are at 10 or 11 keys and all keys available on the German, American, and English keyboard for MD5, and Wordbook for MD5, and the whole LAN manager stuff and that. We're working on a decked Rainbow Table Lookup service there. ISC and Java servers are in that network. You will find Hackend ISC servers in there. This is also a commonly used ISC network among CCC. The official CCC Java server has a leg in there. FTP CCC DE is there, so you can download stuff without people seeing what you're downloading there. We're making high-performance computing available there. Some people had just too many ATI and NVIDIA graphics cards and decided to get them together because they're very useful when it comes to the some points upstairs, the Rainbow table. We kind of cloud computing. We can stream multimedia events. So if you have a talk in a hackerspace, you can just stream that to a different hackerspace and watch it there. And the very interesting thing is you can kind of pick the nationality you go out to the traffic. So if you want to, you can choose proxies to become German, Dutch, American, or whatever is on the ChaosVPN. And more stuff still not mentioned and working here. But I think a lot of you are interested in the CTF, and now we'll come to the CTF with the virus.
I apologize in advance for sounding like a dead frog. Voice is still recovering from last night. Forgot to move that picture. So the Warzone is more or less a copy of the original ChaosVPN/AgoraLink network. It's just another spun up instance of the same thing, but used for an entirely different purpose. The AgoraLink ChaosVPN network is, designed to be just universities, hackerspaces, people learning all the time, people mirroring talks between one space or another. The VPN tunnels that we, would test beta software on, VoIP channels for people to, call back and forth in the middle of a talk. Maybe there's a talk going on at PS1 that somebody in New York really wants to watch, and they want to ask questions and stuff like that. Warzone is just all pain all the time. The idea is to build this entirely isolated no man's land of data, where each node gets its own little chunk of the network to host whatever game they want to host. We come up with a kind of a loosely adapted global scoring system, and people just lay into each other. So if it's on that network, it's hostile. So Warzone is like AgoraLink, but evil. The idea is, right now, for the most part, the concept of a CTF or challenges that are very similar, most of the time are relegated to a conference setting. You either go to a camp or you go to a con, and there's only so many games you can run because you only have a certain amount of time. Moving hardware around the world is expensive, so sometimes there are types of challenges that aren't accessible. A lot of the offline challenges that people play, like Root Wars, are kind of niche and very tiny, and there's no scoring linking. So there are built-in limitations to playing these kinds of games in a conference setting. So the idea of the Warzone is to give this other space where anybody with an idea or with a concept can host these ideas all the time, hopefully so that there's some more freedom for more exotic challenges at some of the conferences. German keyboard cannot use. So the targeted groups for people playing on it, obviously hackerspaces, kind of the point. University groups, security research groups, anybody who's just looking for an ever-present, ever-evolving CTF-style challenge, just constant brain teasers, people keep going. So the layout of the network is each node on Warzone is given a /24, and the .1 of that /24 is your info page. Where basically, if you're on a node and you decide you want to go play somebody's game, you look up the giant directory and you go, oh, it's PS1's hosting some game. I'm gonna go talk to them. So you go to their .1 and there's this web page that has all of the services that they're hosting and how to play and how to score and all the, the ins and outs of whatever their challenge may be. And the idea is that this .1, whatever the gateway is the only part of each node that's not malicious. This is the portion where you find out how to play, not the portion that attacks you. And there are rules, obviously. I'm not going to go over these particularly because we're still kind of forming, how this is going to work. And there'll be a more permanent fixture. But the idea is basically anything goes as long as you don't attack the hosting network itself. Whether it be botnet challenges, people hosting web stuff, or you can log in and elevate credentials. At NullSpace, we're actually talking about a project where we'll take live malware and defang it, but leave the infectious portions and hide keys in them and let people download them and try to launch them at each other. Anything goes as long as you're not stopping other people from playing. That's the spirit of the rule set. Yeah, that's you wanna give the fly. You wanna give the ending thanks?
Oh no, you can do that if you.
No, that's cool.
Okay, there's some guys we need to say thank you for that. No, first of all, any questions regarding the CTF stuff? You don't have a lot of questions today, does it? Is that connected to the Ninja party last night? Okay. We need to say thank you to several people. One of them was Hega, who has built up an idea of the VPN for the phone system years ago. Goose, who's the developer of tinc. He pretty much likes our hackerspaces, and tinc development is done at the moment. Together with us, you have seen some wishes for the future. Eric Michaud is one of the Americans who kept the pressure, and OpenFly, who's doing the images, for example, for the Fonera. And a lot of other people who's helped to contribute in the code and stuff like that. Yes. And we have a wiki where we contact all this information. This wiki is the Hamburg CCC wiki, and if you enter ChaosVPN in Google, it will directly get you there. The source is at GitHub, so if you want to have a look in what we are doing, you can just do that very easy. The tinc website is tinc-vpn.org. And yeah, usually you will find us on the Hackend IRC as mentioned on the channel #ChaosVPN. Are there any questions? 2. Okay.
The Warzone and the ChaosVPN are running on the same network. You're just logically saying, don't attack these networks, only stay over here, or how's that work?
No, they're 2 separate networks. It's this. Okay, the question was if Warzone and ChaosVPN are 2 different networks, or if they just don't attack each other rule. There are 2 different networks. One of the reasons is ChaosVPN is only for hackerspaces, while Warzone is also for university and security groups and other groups of interested people. So it's different target groups, different ideas. It's just the same stuff we're using. Yes. This is just, we did it for us, but it's all open source, and we already have a lot of feedback from people who use it for their own network. I think the general idea to have a mesh network and the general requirements we have are requirements that a lot of people have to the network. This is why it's open source. There's documentation how to set it up for yourself. You'll just all find that on the wiki. And we have a network image from the ChaosVPN to give an impression of the size. Shall we just show that? Yeah. Are there any more questions? Okay, then I'll try to find. So if you want to get involved in one or another, just as we still have some time left, come over here and we can exchange data. All the information you will need is on the wiki. Just Google for ChaosVPN, and if you want to be more detailed, Google for ChaosVPN, CCC, and Hamburg. You will find that. Yeah, there's one more question.
Yes, since there are two different networks, do you need different devices?
There is a setup. Since there are two different networks, do we need two different devices? The answer is no. If you use a decent computer with more than one network card, or if you use the Fonera. The switch on the Fonera access point supports VLANs, so you can put ChaosVPN on one port, network without any ChaosVPN at all on the second network. Then you can do Warzone on the third network, and for example, anything totally different on the fourth port.
Ting is using this TON device, so you can set up more than one tunnel, which is basically the concept behind Ting. And you don't have any problems running two or more instances of Ting at the same time. It's working pretty good for me.
This should be an overview of the network status at this minute. This page is generated every minute and it's a bit slow. It shows all the nodes on the star of the network. Are there any more questions as this is loading?
We wanted to get on like the Warzone, what designates a security group?
Sorry?
So the question is, what designates a security group on the Warzone? Both networks are Web of Trust, so ask and find out.
More questions?
Yeah, go ahead.
Okay. Well, the star is loading very slowly as it's a very big image. We'll just keep it loading, maybe post it up. And first of all, thank you for staying here and talking and listening. If you want to get involved in one or another, feel invited to just come in the front. And yay. Hello. It's 1 p.m. now, and you're sitting in room 5. So if you have read the schedule right, that means you're in the ChaosVPN CTF Gaming Network talk. So I'd like to get some information about the audience first. So who of you is involved in a hackerspace? Who of you is involved in CTF gaming? That's a bit less, but also interesting. Okay, and who of you has experience with network? Good. Okay. This talk is about ChaosVPN CTF Open. Together with some people, I co-hosted the CCC CTFs, and I like to travel hackerspaces and have some friends around the world in different hackerspaces which I'd like to communicate to. Any questions for the speakers? So I will explain how we got to all of this. So, has any one of you been on Hackers at Random? Some? See 2 or 3? Hackers at Random is a CTF gaming network. Who we are? Root. This is Jens Mücker. He's an OpenWRT developer. He codes for his daytime job. And he has written a lot of the code we needed to write. Then we have Vyrus. He's with DC949. He did the OCTF or worked with the OCTF 1 to 5. He's layer 1 needs to be mentioned. I don't want to read all the slides. You can read that. Yeah, he's one of the co-founders at Nullspace Labs and did some other interesting things, especially regarding CTF, capture the flag. Dutch camp, hackers camp in usually the swamps somewhere. This time it was not too bad. We talked a lot about that. It is a problem to communicate on the network between the different hackerspaces. Also, we wanted to play CTF, and we were playing CTFs. But you know, hosting a CTF is a lot of work. And most of this work is the same work all over again. It's the network setup. So there was an idea born. We wanted to play CTFs in our rooms. Most of us had hackerspaces. And this required a VPN setup. And to reduce the work on that, we decided to make hacking networks. Then we have Eric Taves. He's from the Chaos Computer Club Darmstadt. He studied computer science. He's working at the TU Darmstadt now and is interested in cryptography, cryptanalysis, and stuff like that. You might know his software to break WEP in less than 60 seconds. Oh yeah. And then there's me. I'm from the Chaos Computer Club Hamburg. I'm an administrator for the daytime job. I played a lot CTF with the University of Darmstadt. For example, USB CTF. Some of you might know Cypher and